Okay, so I just want to talk a little bit about the project. So now we're going to combine, um, well, there's going to be a lot of coding that we've learned this entire semester so far that we're going to combine. But the reason I say this is just like an extended homework problem is because what happens is a lot is going to be most directly based on what we've seen this week. And again, you're just going to turn this in as your homework that's due um, like it's today's Saturday, not the Monday that's like 2 days from now, but the Monday after that. And you're going to write a class, and it's going to be called My Function, and it's going to do several things. So you're going to create a function, and you are going to, as the use of the class down here indicates, you have a Python function here where we're thinking about this like as a math function. Here it returns x squared. We're creating an object. It's an instance of the class myFunction, and we're passing in this parameter testFun, which tells you up here in the init method we need to have testFun here as an argument. And just to sort of give you one hint, there's probably going to be more that you're going to want to put here, but I don't know. You don't have to. Self.fun is going to be equal to fun, whatever function gets passed in there. I'll just call it f. Self.fun is equal to f. And there's going to be three different methods. One is going to be integrate method, a differentiate method, and a plot method. So if you look at integrate, what you pass in is you don't pass in the function because the function is part of the class. You pass in the left endpoint, the right endpoint, and your tolerance. That is how close you want successive approximations to be before you end the loop. Okay, now I want to point out two things. Whatever code you have up here, it cannot explicitly have like this function. So for example, you're going to pass in testFun, but the only way that you can access this function is through this f here and by referring to self.fun here. So for example, if you have a function here, like this is testFun, it would be completely wrong if I had testFun written anywhere up here. So inside the class, it can only refer to stuff that gets passed into the class, which is going to be things like this f, this a, the b, the tolerance, and that sort of thing. Differentiate is going to be a similar story. And finally, the plot here, this plot, when I run this, when I do myfun.plot01, it should just print out a NumPy plot or a matplotlib plot. Not return a plot that you print out or something. It should just display a plot when you do something like this. So I've right here, I've done this myself. I just want to show you a couple of things. So my code up here doesn't explicitly refer to testFun. The only way it has access to this function is because I've passed it in here as testFun. And now when I run this with the tolerance, with the default tolerance, which is 0.1, you get 0.21875. But I should be able to run this with higher and higher tolerances to get better and better approximations. Okay, so now, for example, since up here my class is written up there, I guess you got a little glimpse there, but again, all you're really doing is copying and pasting the numerical integration thing we did into this function, okay? And trying to, the hard part about this, about the class part, is making sure you have things correct with scope. So now if I come down here and change this to x cubed, and instead of calling it testFun, let's just say I call it tf, and do something like this. When I run this, I should get basically the integral, or not basically, I should get the integral, the approximate integral from 0 to 1 of x cubed, which should be close to 0.25. And if I make the tolerance more and more and more. Okay, so now what I'm saying is, before I had testFun, so this is what I had before. If in my class definition up here, which I haven't, which I'm hiding from you, if I had like testFun written there explicitly, and then I deleted that and used tf here and tf here and changed this to x cubed, if I'm using testFun, if I'm explicitly referring up here to the testFun down here, when I test your code and change it from testFun to tf, there's going to be errors and you're going to have to do it again. Okay, so I hope that makes sense. If not, just let me know on the forums. Really, we're just doing these three different things. We've done each of these. We've integrated. We've done the numerical integration. We've done the numerical differentiation. We've done the plotting. We've looked at classes. Now you're going to have to combine those two things. So it's a little more complicated than, I think it's more complicated just from a programming standpoint than some of the things we've done before. And it still sort of implicitly incorporates some of the things that we did before, just the basic coding skills, use of NumPy, that sort of thing. Okay, so that's it for the project. If you have questions about the project, let me know. Everything, so today is Saturday at 2:30. I'll be sending an email once I get everything posted up in Canvas, but it should be very shortly. Probably by the time you've seen this video, everything has been posted.